Hey guys, welcome back to Petroleum Downstream Crash Course. In this video, we're going to be exploring real-life designs of distillation columns. So, I'm going to tell you a little more about the designs that are available online, specifically the designs available in Google Patents. So what you do is go to google.com/patents. And this is where you can find all sorts of patents that are available. I'm going through patent US1997675 A. And what you can find on this page is the patent number, when it was published. This one was published in 16 April 1935, and it was filed in 28 August 1930. You can see the inventors and the original assignee, which is the company which this patent was assigned to. Additionally, if you're a little more academic, you can actually download the references in EndNote bibliotext format. Okay, so without further ado, let's go through the patent. So first, we want to download the PDF. Okay, so yeah, opening the we're opening the Reader app. Okay, so in this diagram, what you can see here, in this patent, there's a diagram of the distillation towers, as explained earlier. See the atmospheric tower, the steam column, the stripping steam column, and of course the vacuum tower. It's a bit hard to read it sideways, so let's just snip it out. Okay. So to help us see it better, we can actually put the snippet of the diagram onto Word. Let us just flip it around. Rotate. This where makes it a lot easier to see the whole layout of the distillation setup. Don't be afraid when you see lots of data here. Let's just go through it slowly, right? So this is this paragraph is talking about a distillation system and how it works. What's the objective of this distillation column? So the objective of this invention is to reduce the pipe still temperature in which a liquid must be heated in order to vaporize a fraction thereof. Basically, what is this saying is to lower the boiling point of the crude oil vapors. So you can remember what was talked about earlier about the vacuum distillation column. So this is just extra description of what it's all about. Why are they separating it? Figure 1 shows a diagrammatic scheme or plan of the distillation system. So this is figure 1. Figure 1. Alright, figure 1. And this is figure 2. This is a very old pattern, so it's still typewritten and hand drawn. Okay? So it's just saying, yeah, you can use it for distillation, but you can use it for lots of other stuff as well. So from line 52 onwards, it's going to talk about how it works. So it's introduced into the reflux coil in the atmospheric tower. Oh, it starts here. In the system, diagrammatically illustrated in figure 1, crude is heated in a pipe still. Gasoline and lights are flashed in the tower. Part 11. So, let's go. Where does it start? Oh boy. Yes, there you go. Crude feed. So what's the crude feed do? It passes through the atmospheric tower. Well, basically, you've seen some preheating being done before. So what this does is to actually conserve the heat or that's being used in the tower. This is known as heat integration, so you can reduce the boiler duty. Alright, so the idea behind distillation is that you must have a condenser on top. So you need a cool fluid to cool the vapors that run overhead, which is a mixture of steam and naphtha. So to cool that down, you need to take heat away from that. However, at the same time, you need to heat up your crude oil in order to get it to be distilled. So instead of using cooling water to cool down the vapors and a heater to heat up the crude oil, what you can do first is to preheat the crude oil by running it through the condenser section of the column. Okay, so what it does, it goes into here, this top part, which is number 14. It's introduced through pipe 13 into reflux core 14 in the atmospheric tower. This is to provide reflux. The preheated crude is just then conducted through pipe 15. Pipe 15 is here. Pipe 15, coil 16, pipe 17, coil 18, blah blah blah, heat exchangers, blah blah blah. So the whole idea of this is to preheat the crude oil. So you see it goes from here, down here, to heated a second time. So this is cooling the gas oil that comes out. You can see this is the stripping part, where the stripping columns where the steam is being pumped in. See steam here, steam being pumped in to the top to strip off the light vapors. And what you get is the gas oil that comes out. GO stands for gas oil. So gas oil comes out and it's hot. So you kind of want to cool it down, right? So to cool it down, you can pump the cooler crude oil through to exchange heat with the gas oil so that the gas oil cools down and the crude oil heats up. So again, we follow through pipe 17 onto the vacuum tower. So again, the oil here is being used to cool down, you cool down the vapors overhead. And then it goes through here and down into these three heat exchangers. So it does the same thing. There's going to be probably vacuum gas oils. This is also vacuum gas oil because this is a vacuum tower. So what comes out is usually the vacuum gas oil. So they call it the heavy oil cut and the medium oil cut in this case. However, it's basically the same idea, right? And of course there's residue that comes out here. Can you see? So it comes from the bottom of the vacuum tower into this heat exchanger and comes out. So residue, the heavy gas oil and heavy vacuum gas oil and the other vacuum gas oil. I'm not too sure the boiling points, alright? But still, the idea is that you heat it up to conserve heat and energy. So, once the crude oil is done here, it goes all the way into this pipe still. This pipe still is labeled number 10. So it is heated in this pipe still. So what happens in this pipe still? Goes through to the heat exchanger here and goes in. So this is a place where you kind of heat up your crude oil. It works like the furnace, I suppose. So once the crude oil is heated, it goes through this heat exchanger coil and goes through pipe 30 into the atmospheric tower. So that's the whole preheat train. This is called a preheat train, right? Preheat train into the furnace, which is called a pipe still, and it goes into the atmospheric tower. So see, these lines will actually tell you how it works, where the crude oil is going through. So tower 11 is here. See this 11? This is 11, tower 11 is an atmospheric tower. So it's an atmospheric pressure, it's provided with baffles, blah blah blah. So light oil cut is removed from intermediate point by pipe. So pipe 32 is here. So they take some oil out. Alright? Okay, so the light oil cut will come out from here. You can see the bottom. Alright? So blah blah blah, light oil cut comes out removed by pipe 32, and the gas oil cut is removed at the high intermediate point 33. So this is where the gas oil is being cut from in the actual atmospheric tower, and the stripped vapors and the gases are returned to the tower through pipes 32A and 33A respectively. So you can see this. So remember we talked about stripping steam. So the pipe that carries the stripping steam back into the atmospheric tower is this pipe 33A and pipe 32A. So remember the diagram before in the atmospheric tower tutorial or video. You can see this in action now in a real invention. Okay? And one more thing you notice is that this stripping tower is actually like one big tower right over here. See? It's not like separate towers for every single one. It may be more economical to do it this way. Okay? So gas oil is withdrawn through pipe 35, preheater 36, blah 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 blah, into a suitable storage tank. So let's look for pipe 35. Pipe 35, where are you? So I think this is gas oil. Let's trace it back. Yes, pipe 35, here you are, pipe 35. So the gas oil comes to preheat the crude feed and comes out here. So these are several heat exchangers and coolers to cool it down to a suitable desired temperature to storage. Okay? The part of the gas oil, blah blah blah, is returned by pump 39A to the top of the vacuum tower 12, where it serves as reflux. So, in this design, what they do is they take part of this gas oil, they pump it as a reflux. So you can see it's not necessary that this reflux comes from the same tower. You can use the gas oil from one tower to use it as reflux in the other tower. So it all depends on design. There's a lot of there are many variations you can do reflux. This is just one of them. Okay, so the residue or bottoms or reduced crude is withdrawn through the base of tower 11 through pipes 48 and 49 to the upper bank of convection coils, blah blah blah. So you can see that this is pipe 48. This is the bottom of the atmospheric distillation column tower. So it comes through here, and this is actually just long residue. In this pattern, they call it reduced crude. Okay, so in this case, the reduced crude goes into the pipe still. So it gets heated in this pipe still along with recycle, but never mind. It just gets heated in this pipe still, where it's heated to a similar temperature. So of course to prevent the cracking. And it goes into the vacuum tower at atmospheric pressure. But of course at the vacuum tower the pressure is much lower because of this ejector, which is the pump that is meant to draw all the vapors out of there to reduce the pressure in this vacuum tower. So at the bottom of the tower is about 100 millimeters mercury, I guess. I think this is 100 millimeters mercury. Let's check. Yep. I'm not so sure yet. Maybe you'll find it in the rest of the pattern. But basically, what the pattern does is to explain to you how this invention works. Alright, where does the flow go from where to where? And then you'll make explicit references to these diagrams. And then blah blah blah. It's going to do that for a few more pages, or rather just these two sections. You can see this part highlighted. Oh, sorry. This part highlighted here in red, and of course here. So here they go on to explain how the vacuum residue works. The vacuum tower actually works. So residues blah 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 is going to be at the base of the vacuum tower. So this is the base of the vacuum tower. It's over here. The base of the vacuum tower is in this area. The heavy oil cut we taken through tower 12 at pipe 54, I believe 54, and the medium oil cut. The medium oil cut may be withdrawn at higher point 155. So you can see these are the light and heavy vacuum gas oils. Excuse me. So what else? How does it work? Medium coil cut from stripper goes to into stripper 56. So this is the stripping tower. Well, I have mentioned before that not all vacuum towers actually use stripping steam for various reasons. In this separate stripper, they may just put stripping steam here and they won't bother so much with this cut. But in this invention, this very old invention of the vacuum tower configuration, they use stripping steam here. You can see the steam here. So it's not necessary, there's no hard and fast rules as to whether you should use steam or not. Just the idea is to get the maximum quality for the minimum price. So if it's cheaper not to use steam, they'll probably not do it. Okay? But in this case, they do. Alright, for some reason. Yeah, some reason, okay? I'm not that sure of the reason. Okay? So the non-volatile residue, which is the, what is this called? This is called short residue. Short residue comes from the vacuum tower. Short residue comes from the vacuum tower, and it goes to, yeah, it goes to be stripped by pipe 68. Ah, there you go. So where does it go? This is the recycle, it goes back here. Ah, yes, there you go. So you see? Okay, so what they do is that they get the vacuum residue from the bottom of the vacuum tower. Part of it goes into a stripping section where they strip it with steam, so that the steam, stripping steam and lighter vapors go back into here. And what comes out? Here is just residue. Okay? Residue. Yeah. And for some reason, part of the residue is forced back by pump 84 through pipes 85 and 49 through the upper bank of the convection tubes. So basically what they do here, this is they go and recycle here. They take part of the residue and recycle to kind of reheat everything here. So you can think of it as a reboiler configuration. So this is in essence like a reboiler to kind of boil off more vapors. So in this case, they do have the reboiler here, and the stripping steam configuration here. So this is not what they usually do in the modern distillation tower design. Usually they'll just strip it off with steam, but this is a 1935 or 1930s design, so maybe it's a little different from what you have today. Alright? So yeah, that's basically how the whole thing works. And of course, a conduit. Let's talk about the top part of the vacuum tower. Alright? Top part of the vacuum tower. Conduit at the top of the vacuum tower comes with a booster ejector and a barometric condenser. So this is where, what do you call that? They condense the vapors because you're injecting steam in here, injecting steam and light hydrocarbon vapors. Then they're going to condense it all in here. So at the top they withdraw gas on, and of course the water, which is number 81. Water is withdrawn by pipe 81, gas oil, pipe 80. So probably this will be a heavy gas oil cut. It's not the same as the gas oil here. Not exactly the same anyway. Right? You get the idea. Alright? Alright, yes. Absolute pressure at the base of the tower is 100 mm. Top of the tower is 70 mm. I'm assuming it's mercury. So they go on to tell you lots about the temperatures of each of the sections. 730 degrees Fahrenheit, and of course 600 degrees Fahrenheit. Okay. The crude oil is passed through the... Oh, this is a summary. Okay. So you don't have to read the whole patent, but this definitely tells you a lot of the rationale about how the thing works. So if you are looking for diagrams and schematics, a good place to look is patents. You can see roughly what the whole invention looks like. You can see the design rationale. If you're going to read all this stuff, which I'm not going to go through now because it's going to take very, very, very long. Alright, but if you want, you can put your what do you call that? If you are interested in me going through patterns of this kind of thing in more detail, please do leave comments below. I may, if I have the time to produce, I may produce more of such videos in the future. But just to give you a real life example. And of course, one more tip and trivia for you, or rather a question for you. Your homework question: who is Standard Oil? I mean, this is the most one of the most important oil companies. But why isn't it here today? Post your answers in the comments below. This is something good you should know about the history of oil companies. Okay, so other than that, that's all I have for you this video. We've just gone through a patent of a distillation column. Okay, patent of a distillation column, gone through the diagram, and explained to you roughly how it works and some of the designs of it. Okay, so I hope you've enjoyed this video, and if you're looking for diagrams, you know where to look for them. Alright, okay, see ya, bye.